You know, it's kind of funny. We've got these incredibly powerful AIs that can write poetry or build an entire app from scratch, but then they get stumped by a simple logic puzzle. It's a weird paradox, right? Well, there's a new AI model that's taking a totally different path to thinking, and honestly, the results are really shaking things up.
This is the big question, isn't it? Why do these massive, globe-spanning models sometimes just hit a wall when it comes to pure step-by-step reasoning? It's one of the last major hurdles in the race for true artificial intelligence, and it's exactly the problem a small team of researchers decided to tackle head-on.
So here's how we're going to unpack this. First, we'll look at why AI has this reasoning problem in the first place. Then, we'll meet the new brain-inspired model designed to fix it. After that, we'll see how it did in a head-to-head showdown with the giants. And you're going to want to stick around for the last part, a really surprising discovery about what made it work so well. All right, so to really get what makes this new model special, you first have to understand how most AIs think right now. The go-to method is something called chain of thought. And, well, it turns out it's got some pretty serious weak spots. So what exactly is chain of thought, or COT? Just think about how you solve a tricky word problem in math. You don't just magically know the answer, right? You break it down. You say, okay, first I do this, then I take that result and do that. COT is basically just teaching AI to do the same thing, to show its work step by step. It's a pretty brilliant way to copy how we humans reason through things. But here's the problem. It's not perfect. Researchers have pointed out a few big flaws. For one, it's brittle. That means if the AI messes up just one step in the chain, the whole thing can fall apart. It also needs a staggering amount of data to learn, and it can be really, really slow to come up with an answer. So it's clever, but it's not always the most efficient or reliable way to think. So if chain of thought is the problem, what's the solution? Well, this is where the hero of our story comes in. It's a new model called HRM, and it was created by scientists who wanted to try something completely different. This new approach comes from a company called Sapient, based out in Singapore. And what they've built is called the hierarchical reasoning model, or HRM. The idea behind it is just fascinating. The whole design of HRM is actually inspired by our own brains. Think about it. We have different mental gears, right? There's the slow, careful, big picture thinking, and then there's the fast, almost instinctive calculation. HRM mimics this. It has a high-level part for abstract planning and a low-level part that just crunches the details at lightning speed. Now, to really understand how wild this is, let's just talk about size for a second. The biggest AI models out there are estimated to have something like 4 trillion parameters. I mean, that number is just astronomical. It's hard to even wrap your head around. Okay, now look at this. The new HRM model, it has just 27 million parameters. That's not a typo, it's not billion, it's million. It is thousands of times smaller. We are talking about a true David versus Goliath situation here in the world of AI. So how in the world does this tiny model punch so far above its weight class? Well, it thinks in these quick, iterative bursts. The big picture planner makes a move. The fast calculator executes it. Then it looks at the result and asks itself, is this good enough or should I go for another round? It's a much more dynamic and, frankly, a much more efficient way to problem solve. A clever design is one thing, but you gotta prove it works, right? So it was time for the main event, the benchmark battle, pitting this little model against the undisputed champions of the AI world. And the testing ground for this was the ARC-AGI benchmark. Now, this isn't some simple test. It's designed specifically to measure pure abstract reasoning. It's a notoriously brutal exam that even the best AIs really struggle with. This is the real deal when it comes to testing AI intelligence. And the results were just stunning. HRM didn't just hold its own. It flat out won. It beat leading models from giants like OpenAI and Anthropic. Just let that sink in. This tiny 27 million parameter model outperforms systems that are orders of magnitude larger and more complex. It proved that a different way of thinking could be more powerful than just raw size. And it wasn't a one-off. The model also aced tasks that are famous for tripping up huge language models, like solving really complex Sudoku puzzles and finding the most efficient path through a maze. These are pure logic challenges, and HRM just sailed through them. But hold on, because the story doesn't end there.
When other researchers went to double-check these incredible results, they stumbled onto a fascinating twist. There was a secret sauce they hadn't noticed at first.
So the people who actually run the ARC AGI benchmark decided to verify the results themselves. This is totally standard in science. And yep, they confirmed the high scores. The model really was that good. But in the process, they found something that wasn't really emphasized in the original research paper. And here it is right from the organizers themselves. They discovered what they called an underdocumented refinement process during training that was actually driving a huge part of the performance. This, right here, was the secret ingredient. So what does that actually mean? It means that while the two-part brain-inspired design is cool, the real game changer might have been how the AI was taught. The specific technique they used to train the model and refine its answers was possibly even more important than the architecture itself. So let's just quickly sum this all up. We've got a small, super efficient AI inspired by the human brain that can literally out-reason the giants. That's amazing. But maybe the biggest takeaway of all is this. Its success is a powerful reminder that in AI, how you teach the model can be just as important, if not more so, than how big it is. Which really leaves us with this massive question for the future of AI. Where do we go from here? Do we keep racing to build bigger and bigger models, these enormous AI brains? Or is the real frontier in discovering smarter, more elegant ways to train them? This little model from Singapore seems to suggest the answer might just be the latter.